Imagine a moment when the vast silence of space is broken by a sound, a faint, almost imperceptible signal that defies explanation. What if I told you that this sound, detected from an object hurtling through the void, could be a message from beyond our solar system? Today, we dive into the enigmatic world of interstellar asteroids and the 25 mysterious signals they've sent our way. These signals, some faint whispers, others startling bursts, have left scientists scratching their heads and sparked endless debates about their origins. Are they natural phenomena, or could they be something far more extraordinary? Join us as we unravel the secrets of these cosmic visitors, exploring their strange behaviors, unexplained patterns, and the tantalizing possibility that we might not be alone in the universe. By the end of this journey, you'll discover why these signals are more than just scientific curiosities. They're windows into the unknown, challenging everything we think we know about space. Ready to uncover the mysteries? Let's begin. Now, let's turn our attention to the first of these mysterious signals, one that has captivated scientists and stargazers alike, the Oumuamua anomaly. In October 2017, astronomers detected an object unlike anything they had ever seen before. It was moving at incredible speeds, and its trajectory made it clear this was no ordinary asteroid or comet. This was Oumuamua, the first known interstellar visitor to our solar system. What made Oumuamua so extraordinary wasn't just its origin, but its bizarre shape. Unlike the typical round or lumpy asteroids we're used to, Oumuamua was elongated, almost cigar-shaped, stretching hundreds of meters in length. This unusual form sparked immediate curiosity and speculation. But the intrigue didn't stop there. As scientists trained their instruments on Oumuamua, they detected faint radio signals emanating from it. These signals were weak, almost ghostly, but they were there, and they didn't match any known natural phenomena. Theories began to swirl. Could Oumuamua be a fragment of a distant planet shattered by some cosmic event? Or was it something far more intriguing, a piece of alien technology, perhaps even a probe sent by an advanced civilization? The truth is, we still don't know. Despite years of analysis, Oumuamua's origin and the nature of those strange signals remain a mystery. What we do know is that this interstellar visitor has opened our eyes to the possibility that the universe is far stranger and far more mysterious than we ever imagined. And as we'll see, Oumuamua is just the beginning of the cosmic enigmas waiting to be unraveled. But the mystery of Oumuamua didn't end with its strange shape or the faint signals it emitted. As astronomers continued to track its journey through our solar system, they noticed something even more baffling. Oumuamua was accelerating. Now, this might not sound unusual at first. After all, objects in space are often influenced by gravity, which can cause them to speed up or slow down. But here's the thing, Oumuamua's acceleration couldn't be explained by gravity alone. It was moving faster than it should have been, and no one could figure out why. This unexpected behavior sent scientists scrambling for answers. One of the leading theories suggested that Oumuamua's acceleration might have been caused by something called solar radiation pressure. Essentially, as sunlight hit the object, it could have pushed it forward, much like how a gust of wind propels a sailboat. But there was a problem. Oumuamua's shape and size didn't quite fit this explanation. For solar radiation pressure to have such a significant effect, the object would need to be extremely thin and lightweight, almost like a giant solar sail. And while Oumuamua's elongated shape was unusual, there was no evidence to suggest it was that thin or reflective. This led to another, more tantalizing possibility. Could Oumuamua's acceleration be the result of alien technology? Some researchers speculated that the object might have been equipped with some form of propulsion system, perhaps even a light sail designed to harness the power of starlight. If true, this would mean Oumuamua wasn't just a random piece of space debris. It could have been a deliberate creation sent by an advanced civilization to explore the cosmos. Of course, not everyone was convinced. Skeptics argued that there had to be a natural explanation, even if we hadn't discovered it yet. They pointed out that our understanding of interstellar objects is still in its infancy, and Oumuamua might simply be the first of many strange visitors that challenge our assumptions about the universe. Despite years of study, the truth about Oumuamua's acceleration remains elusive. Was it a natural phenomenon we've yet to fully understand, or something far more extraordinary? For now, all we can say is that Oumuamua has left us with more questions than answers, and that's what makes it so fascinating. As we continue to explore the cosmos, perhaps we'll uncover more clues that shed light on this interstellar enigma. But for now, Oumuamua stands as a reminder that the universe is full of surprises, and sometimes the most extraordinary mysteries are the ones we least expect. And speaking of surprises, our next signal takes us to another interstellar visitor, Comet Borisov. But this comet brought its own set of mysteries, starting with its unusual chemical composition. Let's dive into that next. Now, let's turn our attention to another interstellar traveler that captured the curiosity of astronomers, Comet Borisov. Discovered in August 2019, Borisov became only the second known object to visit our solar system from beyond the stars, following in the footsteps of Oumuamua. But unlike its predecessor, Borisov looked more like a typical comet, complete with a glowing tail and a fuzzy coma. At first glance, it seemed like just another icy visitor from the depths of space. However, as scientists began to study it more closely, they realized there was something unusual about this cosmic wanderer. The first clue came from its chemical composition. When astronomers analyzed the light reflecting off Borisov's tail, they detected an unusually high amount of carbon monoxide. Now, carbon monoxide isn't rare in comets, but the levels found in Borisov were far higher than anything seen in comets from our own solar system. This raised an intriguing question: what kind of environment could have produced a comet with such a unique chemical signature? Some researchers speculated that Borisov might have formed in an extremely cold region of its home star system, where carbon monoxide could freeze and accumulate in large quantities. Others suggested it could have originated from a star system very different from our own, one with conditions we've never encountered before. But the mysteries didn't stop there. As Borisov continued its journey through our solar system, faint signals were detected emanating from its tail. These signals were unlike anything typically associated with comets. While most comets emit predictable radio waves as their icy surfaces vaporize, Borisov's signals were irregular and faint, almost as if something else was at play. Some scientists propose that these signals could be the result of interactions between the comet's tail and interstellar dust, creating a kind of cosmic static. Others wondered if there was something more deliberate behind these faint emissions, perhaps a sign of an unknown process or even a hidden structure within the comet itself. The discovery of Borisov opened up a new chapter in our understanding of interstellar objects. Unlike Oumuamua, which defied explanation with its shape and acceleration, Borisov presented a different kind of puzzle, one rooted in its chemistry and the faint whispers of its tail. Together, these two visitors from beyond our solar system remind us that the universe is far more diverse and mysterious than we ever imagined. And as we continue to study these interstellar travelers, each new discovery brings us closer to unraveling the secrets they carry from the depths of space. But the story of Borisov doesn't end here. As we delve deeper, we'll explore the strange behavior of its tail and the theories that attempt to explain the faint signals it left behind. What could these anomalies mean for our understanding of the cosmos? Let's find out. Now, let's take a closer look at the peculiar behavior of Borisov's tail, which left scientists scratching their heads. As the comet journeyed through our solar system, its tail didn't behave like those of typical comets. Instead of emitting steady, predictable signals, Borisov's tail produced faint, irregular emissions that seemed to defy conventional explanations. These signals were so unusual that they sparked a wave of speculation and debate among astronomers. One leading theory suggests that the anomalies in Borisov's tail could be the result of interactions with interstellar dust. As the comet traveled through the vast expanse of space, it may have encountered clouds of fine particles that aren't present in our solar system. These particles could have collided with the comet's tail, creating a kind of cosmic interference that generated the faint, irregular signals. This idea aligns with the notion that Borisov originated from a star system with a very different environment, one where such dust clouds are more common. Another intriguing possibility is that the signals were caused by unknown chemical reactions within the comet itself. Comets are known to harbor a mix of ices, gases, and organic compounds, and under the right conditions, these materials can interact in unexpected ways. Some scientists have proposed that Borisov's unique chemical composition, particularly its high levels of carbon monoxide, might have triggered reactions that produced these faint emissions. This theory raises fascinating questions about the chemistry of interstellar objects and how it might differ from what we've observed in our own solar system. But the mystery deepens when we consider the faintness of these signals. Unlike the bright, clear emissions we typically associate with comets, Borisov's signals were barely detectable, almost as if they were being muffled or obscured by something. Could there be a hidden structure within the comet, perhaps a layer of material that dampened the signals? Or was the comet's tail interacting with an unseen force, such as a magnetic field or a plasma cloud, that altered the way the signals were transmitted? These questions highlight just how little we know about interstellar objects and the environments they come from. Borisov's tail anomalies remind us that the universe is full of surprises, and even the most familiar phenomena can take on entirely new forms when viewed through the lens of interstellar space. As we continue to study these cosmic visitors, each discovery brings us closer to understanding the vast and varied tapestry of the cosmos. Next, we'll explore another enigmatic signal that has puzzled scientists for decades, the famous WOW signal and its potential connection to interstellar asteroids. Could this iconic burst of energy have originated from an object like Borisov or Oumuamua? Let's find out. Now, shifting our focus to one of the most iconic mysteries in the history of space exploration, we arrive at the WOW signal. Detected in 1977 by the Big Ear radio telescope at Ohio State University, this powerful burst of radio waves lasted for 72 seconds and has never been detected again. For decades, it has been a cornerstone of the search for extraterrestrial intelligence, but recent studies have proposed a fascinating new angle. What if the WOW signal wasn't from an alien civilization at all, but from an interstellar asteroid? The idea stems from the fact that the WOW signal was incredibly strong but also incredibly brief, characteristics that don't align with typical cosmic phenomena like pulsars or quasars. Instead, some researchers have suggested that the signal could have been caused by an interstellar object passing through our solar system. Imagine an asteroid like Oumuamua or Borisov, but one that happened to reflect or amplify a natural radio signal from a distant star or galaxy. As it moved through space, its trajectory and composition could have created a brief but intense burst of energy, which we detected as the WOW signal. This theory gains traction when we consider the timing and direction of the signal. The WOW signal originated from the constellation Sagittarius, a region of the sky rich in stars and cosmic activity. If an interstellar asteroid passed through this region, it could have acted as a kind of cosmic mirror, bouncing radio waves toward Earth in a way that made them appear artificial. This would explain why the signal was so strong yet so fleeting. It wasn't a deliberate transmission, but a natural phenomenon amplified by the asteroid's unique properties. Of course, this hypothesis is still hotly debated. Critics argue that the WOW signal's narrow frequency band and precise characteristics make it unlikely to be a natural event. They point out that no known natural process can produce such a clean, focused signal. However, proponents of the asteroid theory counter that we've only just begun to study interstellar objects, and their behavior might hold surprises we haven't yet imagined. After all, Oumuamua and Borisov have already shown us that these visitors from beyond our solar system can defy expectations. As we continue to explore the mysteries of interstellar asteroids, the WOW signal remains a tantalizing puzzle. Whether it was a fleeting echo of an alien civilization or the cosmic fingerprint of a passing asteroid, it reminds us that the universe is full of phenomena we are only beginning to understand. Next, we'll delve deeper into the asteroid origins of the WOW signal, examining the evidence and the ongoing debate among scientists. Could this iconic signal be the key to unlocking new secrets about the objects that drift between the stars? Let's find out. Now, let's take a closer look at the asteroid origins of the WOW signal and why this theory has sparked such intense debate among scientists. The idea that an interstellar asteroid could have caused the WOW signal hinges on the concept of natural signal amplification. Imagine an asteroid, rich in metallic or icy materials, passing through a region of space filled with radio waves from distant stars or galaxies. As it moves, its surface could act like a mirror or a lens, reflecting or focusing these waves into a concentrated burst of energy. This amplified signal directed toward Earth might explain the WOW signal's extraordinary strength and brevity. One of the key pieces of evidence supporting this theory is the signal's narrow frequency band. The WOW signal was detected at a frequency of 1,420 MHz, which falls within the range of hydrogen emissions, a common feature of cosmic radio waves. If an interstellar asteroid passed through a region rich in hydrogen emissions, it could have reflected these waves in a way that made them appear artificial. This would explain why the signal was so precise and focused, yet still fleeting. However, not all scientists are convinced. Critics of the asteroid hypothesis argue that the WOW signal's characteristics are too unique to be explained by natural processes. They point out that no known natural phenomenon can produce such a clean, narrowband signal without any accompanying noise or distortion. Additionally, the signal's sudden appearance and disappearance don't align with the behavior of known interstellar objects, which typically emit more consistent or predictable signals. Proponents of the asteroid theory counter that our understanding of interstellar objects is still in its infancy. With only a handful of confirmed interstellar visitors like Oumuamua and Borisov, we've barely scratched the surface of what these objects are capable of. It's possible that certain asteroids, under specific conditions, could produce signals that mimic artificial transmissions. For example, an asteroid with an unusual shape or composition might reflect radio waves in unexpected ways, creating a signal that appears deliberate. The debate over the WOW signal's origins highlights the challenges of interpreting mysterious phenomena in space. On one hand, the asteroid theory offers a plausible natural explanation for a signal that has puzzled scientists for decades. On the other hand, the signal's unique characteristics continue to fuel speculation about its potential artificial origins. As we discover more interstellar asteroids and study their behavior, we may finally uncover the truth behind this iconic mystery. Next, we'll explore another intriguing signal linked to interstellar asteroids, a faint echo detected years after Oumuamua's passage. Could this be a lingering effect of the asteroid, or is it something even more mysterious? Let's find out. Now, shifting our focus to another fascinating mystery, let's delve into the enigmatic echo signal linked to Oumuamua. Years after this interstellar visitor sped through our solar system, astronomers detected a faint, lingering signal that seemed to echo its presence. This discovery has sparked a wave of curiosity and debate. Could this echo be a residual effect of Oumuamua's passage, or is it evidence of something far more extraordinary? The echo signal was detected in a region of space where Oumuamua had previously traveled, raising questions about its origin. One theory suggests that the asteroid's unique composition, possibly a mix of metallic and icy materials, could have left behind traces of charged particles or plasma as it moved. These remnants might have interacted with cosmic radiation, creating a faint but detectable signal that lingered long after the asteroid had passed. In this scenario, the echo could simply be a natural byproduct of Oumuamua's journey through space. However, not everyone is convinced by this explanation. Some researchers argue that the echo's timing and characteristics don't align with what we'd expect from a natural phenomenon. For instance, the signal appeared to be unusually stable, lacking the fluctuations typically seen in cosmic echoes. This has led to speculation that the echo might not be a lingering effect of Oumuamua at all, but rather something entirely different, perhaps a signal from another source or even a deliberate transmission. Adding to the intrigue, the echo's frequency and intensity don't match any known natural processes. While most cosmic echoes fade over time, this one seemed to persist, almost as if it were being sustained by an unknown mechanism. Could this be evidence of advanced technology embedded within Oumuamua, or even a message left behind by an extraterrestrial civilization? While these ideas remain speculative, they highlight the profound mysteries surrounding interstellar objects and the signals they might produce. As we continue to study these faint echoes, one thing is clear: Oumuamua's legacy extends far beyond its brief visit to our solar system. Whether the echo is a natural phenomenon or something more, it serves as a reminder of how much we still have to learn about the cosmos. Next, we'll explore the theories behind this mysterious echo and what they could mean for our understanding of interstellar asteroids. Stay tuned as we uncover more about this captivating cosmic puzzle. Now, let's take a closer look at the theories attempting to explain the mysterious echo signal tied to Oumuamua. One of the leading ideas centers on interstellar plasma interactions. As Oumuamua traveled through space, its unique composition, potentially a mix of metals and ices, could have released charged particles into its surroundings. These particles might have interacted with the interstellar medium, the sparse gas and dust filling the space between stars. Over time, this interaction could have generated a faint but detectable signal, lingering long after the asteroid had moved on. This theory aligns with what we know about cosmic phenomena, but the echo's unusual stability raises questions. Most natural echoes fade or fluctuate, but this one remained remarkably consistent, challenging our understanding of how such interactions typically behave. Another intriguing possibility is that the echo isn't a natural phenomenon at all. Some scientists have speculated that Oumuamua might have carried advanced technology, either as part of its structure or as a deliberate addition. If the asteroid contained some form of alien machinery, it could have emitted signals designed to persist over time, creating the echo we detected. This idea, while speculative, isn't entirely far-fetched. After all, Oumuamua's unusual shape and acceleration have already led some to wonder if it could be an artificial object. If true, the echo might not just be a cosmic accident, it could be a message or a beacon, intentionally left behind for us to discover. There's also the possibility that the echo originated from an entirely different source. Space is filled with countless objects and phenomena, many of which we're still learning about. The echo might not be directly tied to Oumuamua at all, but rather to something else in the same region of space. For example, a distant star or a previously undetected cosmic event could have produced the signal, coincidentally aligning with Oumuamua's trajectory. This theory highlights the challenges of studying faint, distant signals, where it's often difficult to pinpoint their exact origins. As we piece together these theories, one thing becomes clear: the echo signal is more than just a scientific curiosity, it's a window into the unknown. Whether it's the result of natural processes, advanced technology, or something else entirely, it challenges us to rethink what we know about interstellar objects and the signals they might produce. Next, we'll turn our attention to another mysterious signal, this time from a seemingly invisible asteroid. Stay with us as we uncover the secrets of the dark asteroid signal and what it could mean for our understanding of the cosmos. Now, shifting our focus to another enigma in the cosmos, we encounter the dark asteroid signal. Imagine an object in space that emits radio waves but remains completely invisible to our telescopes. This is precisely what astronomers observed when they detected a mysterious signal originating from what appeared to be an empty patch of space. The signal was strong and unmistakable, yet no visible asteroid or comet could be found in the area. This puzzling phenomenon has led scientists to consider some extraordinary possibilities. One of the most compelling theories involves dark matter. Dark matter, which makes up a significant portion of the universe, doesn't interact with light, making it invisible to traditional observation methods. Could this signal be coming from a dark matter asteroid? If so, it would be a groundbreaking discovery, offering a rare glimpse into the elusive nature of dark matter. The idea is that this asteroid, composed of dark matter, might emit radio waves through interactions with its surroundings, creating a detectable signal without any visible counterpart. While this theory is still speculative, it opens up exciting avenues for understanding one of the universe's greatest mysteries. Another fascinating possibility is cloaking technology. Some researchers have suggested that the asteroid might not be invisible by nature but could instead be intentionally hidden. Advanced civilizations, if they exist, might use cloaking mechanisms to conceal their spacecraft or probes. If this asteroid were equipped with such technology, it could explain why we detect its radio emissions but see nothing visually. This theory, while speculative, ties into broader discussions about the potential for extraterrestrial intelligence and their possible methods of avoiding detection. There's also the chance that the signal is a result of a natural phenomenon we don't yet fully understand. Space is filled with strange and unexplained occurrences, and this could simply be another example of the universe's complexity. For instance, the signal might originate from a dense cloud of interstellar dust or a previously unknown type of cosmic object that interacts with radio waves in unexpected ways. As we explore these theories, the dark asteroid signal reminds us just how much we have yet to learn about the cosmos. Whether it's dark matter, cloaking technology, or something entirely new, this mysterious signal challenges our understanding of what's possible in the vast expanse of space. Next, we'll delve deeper into the implications of such an invisible object and what it could mean for our future explorations. Stay tuned as we uncover more about the invisible threat lurking in the depths of space. Now, let's take a closer look at what this invisible threat could mean for us here on Earth. If dark asteroids exist and are as elusive as the signal suggests, they could pose a significant risk to our planet. Unlike typical asteroids, which we can track and monitor, these invisible objects could approach Earth undetected until it's too late. Imagine an asteroid hurtling toward us, invisible to our telescopes, only revealing itself through faint radio signals. The challenge of detecting such objects in time to take action is a sobering thought. One of the biggest hurdles in detecting dark asteroids lies in their very nature. Since they don't reflect light, traditional methods of observation, like optical telescopes, are useless. Even infrared telescopes, which can detect heat signatures, might struggle if the asteroid doesn't emit enough thermal energy. This leaves radio waves as one of the few ways to spot them, but even then, the signals are faint and easily overlooked unless we're specifically looking for them. The sheer vastness of space makes it even harder, as these objects could be anywhere, silently drifting through the cosmos. The potential consequences of an undetected dark asteroid colliding with Earth are staggering. Depending on its size and speed, it could cause anything from localized destruction to a global catastrophe. The impact could trigger earthquakes, tsunamis, or even climate-altering events, similar to what scientists believe happened to the dinosaurs millions of years ago. The fact that we might not see it coming adds an extra layer of urgency to the need for better detection methods. So, what can we do to protect ourselves? Scientists are already exploring new technologies to improve our ability to detect these invisible threats. One promising approach involves using advanced radio telescopes to scan the skies for unusual signals. By refining our ability to distinguish between natural radio emissions and those that might come from dark asteroids, we could potentially identify these objects before they become a danger. Another idea is to develop space-based detectors specifically designed to pick up on the unique signatures of dark matter or cloaked objects. While the idea of an invisible asteroid might sound like something out of science fiction, it's a reminder of how much we still have to learn about the universe. The dark asteroid signal challenges us to think beyond what we can see and to prepare for the unexpected. As we continue to explore the cosmos, discoveries like this push us to innovate and adapt, ensuring that we're ready for whatever mysteries the universe might throw our way. Next, we'll turn our attention to a signal that seems to carry a musical pattern, raising questions about whether it's a natural phenomenon or something far more intriguing. Stay with us as we explore the harmonic signal and its cosmic implications. Now, let's shift our focus to a signal that seems to carry a rhythm all its own. Among the many mysterious signals detected near interstellar asteroids, one stands out for its almost musical quality. This harmonic signal, as it's been called, appears to follow a pattern that resembles a melody, raising questions about whether it's a natural phenomenon or something far more deliberate. When scientists first detected this signal, they were struck by its regularity. Unlike the chaotic bursts of energy often associated with cosmic events, this signal had a repeating structure, almost like notes in a song. Some researchers have suggested that this could be the result of natural resonance, where the asteroid's composition or shape causes it to vibrate in a way that produces these rhythmic patterns. For example, certain minerals or structures within the asteroid might amplify or reflect radio waves in a way that creates this musical effect. However, the idea of natural resonance doesn't fully explain the complexity of the signal. The patterns detected are not just simple repetitions but seem to follow a more intricate sequence, almost as if they were arranged with intention. This has led some to speculate that the signal could be a form of communication, perhaps from an advanced civilization using the asteroid as a medium to send a message across the cosmos. The idea of an interstellar song is both fascinating and unsettling, as it challenges our understanding of what's possible in the universe. Of course, the scientific community remains divided on this interpretation. While some see the harmonic signal as a potential breakthrough in the search for extraterrestrial intelligence, others argue that it's more likely a rare but natural phenomenon. After all, the universe is full of strange and unexpected behaviors, and this signal could simply be another example of nature's complexity. To better understand the harmonic signal, researchers are using advanced algorithms to analyze its structure. By breaking down the patterns and comparing them to known natural phenomena, they hope to determine whether the signal is a product of chance or design. This process is painstaking, but it's essential for uncovering the truth behind this cosmic mystery. As we continue to explore the harmonic signal, one thing is clear: it challenges us to think differently about the universe. Whether it's a natural resonance or a deliberate message, this signal reminds us that space is full of surprises. And as we move forward, we'll keep our ears open for more clues that might help us unravel this intriguing puzzle. Next, we'll dive deeper into the attempts to decode this harmonic signal and what it could mean for our understanding of interstellar communication. Stay tuned as we explore the science behind the cosmic melody. Now, let's take a closer look at the efforts to decode this enigmatic harmonic signal. Scientists have turned to advanced mathematical tools to unravel its patterns, hoping to uncover whether it's a product of nature or something more deliberate. By analyzing the signal's frequency, amplitude, and timing, researchers have attempted to map its structure, searching for clues that might explain its origin. One approach involves comparing the harmonic signal to known natural phenomena, such as pulsars or magnetars, which also emit rhythmic signals. While these cosmic objects produce regular pulses, their patterns are far simpler than the intricate sequences observed in the harmonic signal. This has led some to question whether the asteroid's signal could be the result of a more complex natural process, such as interactions between its surface and surrounding interstellar plasma. Another intriguing possibility is that the signal's complexity arises from the asteroid's unique composition or shape. For instance, if the asteroid contains crystalline structures or metallic elements, it could act as a natural resonator, amplifying and modulating radio waves into a rhythmic pattern. This theory aligns with the idea of natural resonance but still leaves room for debate, as the signal's structure appears too organized to be purely coincidental. To further investigate, researchers have employed machine learning algorithms to sift through vast amounts of data, searching for patterns that might not be immediately obvious to the human eye. These algorithms can identify subtle correlations and anomalies, offering new insights into the signal's behavior. While this method has yielded promising results, it has also raised more questions as the signal's complexity continues to defy easy explanation. Some scientists have even proposed that the harmonic signal could be a form of interstellar communication, encoded in a way that mimics natural phenomena to avoid detection. This idea, while speculative, highlights the challenges of distinguishing between natural and artificial signals in the vastness of space. If the signal is indeed a message, decoding it would require not only advanced technology, but also a deeper understanding of how an extraterrestrial intelligence might encode information. As the search for answers continues, one thing remains clear: the harmonic signal is a puzzle that pushes the boundaries of our knowledge. Whether it's a natural marvel or a deliberate creation, it challenges us to rethink what we know about the universe and our place within it. Next, we'll explore another mysterious signal that has left scientists equally baffled: a repeating burst that echoes through the cosmos. Stay with us as we uncover the secrets behind this interstellar enigma. Now, shifting our focus to another cosmic mystery, we encounter the repeating burst, a signal that has left scientists both fascinated and perplexed. Detected near an interstellar asteroid, this repeating burst bears striking similarities to fast radio bursts, or FRB, which are intense flashes of radio waves that last only milliseconds. Yet, unlike typical FRBs, which are often one-off events, this signal repeats at irregular intervals, adding another layer of intrigue to its already puzzling nature. Fast radio bursts have long been a subject of intense study, with theories ranging from neutron star collisions to the collapse of distant black holes. However, the repeating nature of this particular burst sets it apart. While some FRBs have been known to repeat, their patterns are usually more predictable. This asteroid-associated burst, on the other hand, defies such regularity, appearing at seemingly random times and with varying intensities. This unpredictability has made it a prime candidate for further investigation, as scientists attempt to determine whether it shares a common origin with other FRBs or represents something entirely new. One leading hypothesis suggests that the repeating burst could be linked to the asteroid's interaction with its environment. For instance, if the asteroid is passing through a dense region of interstellar gas or magnetic fields, it might generate bursts of energy as it moves. Alternatively, the asteroid itself could be the source, with internal processes such as fractures or collisions releasing bursts of radio waves. However, neither of these explanations fully accounts for the signal's irregular repetition, leaving researchers to consider more exotic possibilities. Another compelling theory is that the repeating burst could be the result of advanced extraterrestrial technology. While this idea remains speculative, it's not entirely outside the realm of possibility. If an interstellar asteroid were carrying some form of alien machinery or communication device, it could produce bursts of energy as it operates or malfunctions. This would explain both the signal's repeating nature and its association with the asteroid, though proving such a theory would require extraordinary evidence. As scientists continue to analyze the data, one thing is certain: the repeating burst challenges our understanding of cosmic phenomena. Whether it's a natural occurrence or something more deliberate, it serves as a reminder of how much we still have to learn about the universe. Next, we'll delve deeper into the debate surrounding this signal, exploring whether it's a natural cosmic event or a potential beacon from an advanced civilization. Stay tuned as we unravel the mysteries of this interstellar enigma. Now, as we dive deeper into the mystery of the repeating burst, the question becomes even more intriguing. Is this signal a natural cosmic event, or could it be something far more deliberate? The debate among scientists is as intense as it is fascinating, with compelling arguments on both sides. Let's explore these theories in detail, starting with the natural explanations. One possibility is that the repeating burst is caused by interactions between the interstellar asteroid and its surroundings. For example, if the asteroid is passing through a region of space filled with dense plasma or strong magnetic fields, it could generate bursts of energy as it moves. These interactions might create the irregular patterns we've observed, with the asteroid acting like a cosmic spark plug, igniting bursts of radio waves as it travels. However, while this theory explains the bursts themselves, it struggles to account for their irregular timing and varying intensities, leaving room for doubt. Another natural explanation focuses on the asteroid's internal processes. If the asteroid is undergoing stress such as fractures, collisions, or even internal heating, it could release bursts of energy in the form of radio waves. Think of it like a cosmic earthquake where the asteroid structure shifts and releases energy in unpredictable ways. While this idea is plausible, it still doesn't fully explain why the bursts repeat at such irregular intervals, prompting scientists to consider more exotic possibilities. This brings us to the more speculative yet undeniably captivating theory. Could the repeating burst be an intentional signal from an advanced civilization? The idea isn't as far-fetched as it might seem. If an interstellar asteroid were carrying some form of alien technology, perhaps a communication device or a malfunctioning probe, it could produce bursts of energy as it operates. This would explain both the signal's association with the asteroid and its repeating nature. After all, if an alien civilization wanted to send a message across the vastness of space, using an asteroid as a carrier might be an ingenious way to do it. Of course, this theory comes with its own set of challenges. For one, proving that the signal is artificial would require extraordinary evidence, something we simply don't have yet. Additionally, the irregularity of the bursts makes it difficult to interpret them as a deliberate message. If an advanced civilization were trying to communicate, wouldn't they use a more consistent pattern? These questions keep the debate alive, with scientists carefully weighing the evidence on both sides. What makes this signal so compelling is that it defies easy categorization. It's not just another fast radio burst or a random cosmic event. It's something unique, something that challenges our understanding of the universe. Whether it's a natural phenomenon or a potential alien beacon, the repeating burst reminds us that the cosmos is full of mysteries waiting to be unraveled. As we continue to study this enigmatic signal, one thing is clear: the answers, whatever they may be, will reshape our understanding of the universe and our place within it. Next, we'll turn our attention to another cosmic puzzle, a sudden gamma-ray flash that has left scientists equally baffled. Stay tuned as we explore this explosive mystery. Now, shifting our focus to another cosmic enigma, let's explore the sudden and intense gamma-ray flash detected near an interstellar asteroid. This event was unlike anything scientists had seen before. packing an extraordinary amount of energy into a single, fleeting moment. Gamma-ray flashes are already rare and powerful, but this one stood out for its proximity to an interstellar object, raising questions about its origin and what it might reveal about the universe. One leading theory suggests that the flash could have been caused by a collision between the interstellar asteroid and another object. Imagine two massive rocks slamming into each other at incredible speeds, releasing a burst of energy so intense it lights up the cosmos. Such an event could explain the suddenness and intensity of the gamma-ray flash, but it also raises another question. What kind of object could collide with an interstellar asteroid to produce such a powerful signal? The answer remains elusive, leaving scientists to consider even more exotic possibilities. Another intriguing explanation involves exotic physics, such as the annihilation of dark matter or the release of energy from a highly magnetized neutron star. These phenomena are still poorly understood, but they could theoretically produce gamma-ray flashes of this magnitude. For instance, if the asteroid passed through a region of space where dark matter particles were colliding and annihilating, it could trigger a burst of gamma rays. Alternatively, if the asteroid interacted with a neutron star's intense magnetic field, it might generate a similar flash. These ideas push the boundaries of our current understanding, highlighting just how much we still have to learn about the universe. What makes this gamma-ray flash particularly fascinating is its potential to challenge our existing models of cosmic events. Unlike typical gamma-ray bursts, which are often associated with supernova or merging neutron stars, this flash appeared to originate near an interstellar asteroid, a scenario that doesn't fit neatly into any known category. Could this be evidence of a new type of cosmic phenomenon, one that we've never observed before? The possibility is both thrilling and humbling, reminding us that the universe is full of surprises. As we continue to study this mysterious flash, one thing is certain. It has opened up new avenues of research and sparked fresh debates among scientists. Whether it was caused by a collision, exotic physics, or something entirely unknown, this event underscores the importance of keeping our eyes and our instruments trained on the cosmos. Next, we'll delve into the unusual energy patterns associated with this flash, exploring why they don't match any known cosmic events and what they could mean for our understanding of space. Stay with us as we unravel this explosive mystery further. Now, let's take a closer look at the unusual energy patterns associated with this gamma-ray flash. What makes this event so puzzling is that the energy signature doesn't align with any known cosmic phenomena. Typically, gamma-ray bursts follow predictable patterns, whether they're caused by supernova, neutron star mergers, or other well-documented events. But this flash defied expectations, presenting a unique energy profile that left scientists scratching their heads. One of the most striking features of this flash was its rapid rise and fall in energy. Unlike most gamma-ray bursts, which build up and fade over a measurable period, this event appeared almost instantaneously and vanished just as quickly. This abruptness suggests that whatever caused it was incredibly efficient at releasing energy, but it also raises questions about the mechanism behind it. Could this be evidence of a new type of cosmic engine, one that operates on principles we haven't yet discovered? The idea is both exciting and daunting, as it challenges our current understanding of how energy behaves in the universe. Another unusual aspect is the distribution of energy across different wavelengths. Most gamma-ray bursts emit energy in a specific range, but this flash showed an irregular spread with spikes in unexpected places. Some scientists speculate that this could indicate the presence of unknown particles or interactions, while others suggest it might be the result of a highly unusual environment surrounding the interstellar asteroid. For example, if the asteroid was passing through a dense cloud of interstellar material, it could have triggered a cascade of reactions that produced this unique energy pattern. What's particularly intriguing is how this event forces us to reconsider our models of cosmic energy. If this flash doesn't fit into any existing category, it could mean that our current frameworks are incomplete. Perhaps there are entirely new types of cosmic events waiting to be discovered, events that operate outside the boundaries of what we currently understand. This flash could be the first hint of a much larger and more complex picture, one that we're only beginning to glimpse. As researchers continue to analyze the data, they're also exploring the possibility that this flash might be linked to other unexplained signals from interstellar asteroids. Could there be a connection between this gamma-ray event and the mysterious echoes, harmonic signals, or dark asteroid emissions we've discussed earlier? The idea of a hidden network of interstellar phenomena is tantalizing, and it underscores the importance of studying these objects in greater detail. Ultimately, this gamma-ray flash serves as a reminder of how much we still have to learn about the universe. It challenges us to think beyond the known and to remain open to the possibility of new discoveries. As we move forward, we'll explore another fascinating signal, one that seems to defy explanation even further. Stay with us as we uncover the story behind the silent scream, a signal that appeared and vanished without a trace, leaving scientists with more questions than answers. Now, let's turn our attention to a signal that has left scientists both baffled and intrigued: the silent scream. This mysterious event began with a sudden, intense burst of energy, only to be followed by absolute silence. Unlike other signals we've explored, which often leave behind some form of residual activity or data, this one vanished without a trace, as if it had never happened. The abruptness of its appearance and disappearance has made it one of the most enigmatic signals ever detected near an interstellar asteroid. One of the leading theories suggests that the silent scream could be the result of an asteroid disintegrating. When an asteroid breaks apart, it can release a tremendous amount of energy in a short period, creating a burst that might resemble the initial spike of this signal. However, what's unusual here is the complete lack of debris or follow-up activity. Typically, when an asteroid disintegrates, it leaves behind a trail of fragments or dust, but in this case there was nothing, no remnants, no echoes, just silence. This has led some researchers to question whether the disintegration theory fully explains what happened. Another compelling idea is that the silent scream might have been a failed attempt at alien communication. Imagine an advanced civilization sending a powerful signal across the cosmos, only for it to be interrupted or lost before it could fully transmit. The burst of energy could represent the initial transmission, while the sudden silence might indicate a breakdown in the process. While this theory is speculative, it raises fascinating questions about the nature of interstellar communication and the challenges of sending signals across vast distances. What makes this signal even more puzzling is the absence of any detectable cause. Unlike other unexplained phenomena, which often leave behind some clues or patterns, the silent scream offers no clear explanation. It's as if the universe itself decided to keep this event a secret. This lack of evidence has made it difficult for scientists to develop concrete theories, leaving the silent scream as one of the most enduring mysteries in the study of interstellar asteroids. As we continue to explore these unexplained signals, the silent scream serves as a stark reminder of how much we still don't know about the cosmos. It challenges us to think beyond conventional explanations and to consider possibilities that might seem far-fetched at first glance. Could this be evidence of a new type of cosmic event, one that operates outside our current understanding, or is it a glimpse into the complexities of interstellar communication, hinting at technologies or phenomena we have yet to discover? With so many questions still unanswered, the silent scream remains a tantalizing mystery, one that invites us to keep searching for answers. And as we move forward, we'll delve into another intriguing signal, one that seems to come from not one but two sources. Stay with us as we explore the binary signal, a phenomenon that adds yet another layer of complexity to the story of interstellar asteroids. Now, shifting our focus to what followed the silent scream, we find ourselves staring into an even deeper mystery. The aftermath of this signal is as puzzling as the event itself. Typically, when an asteroid disintegrates or a cosmic event occurs, there's some form of evidence left behind: debris, dust, or even a faint energy signature. But in this case, there was nothing. No fragments, no residual energy, no trace of what caused the initial burst. It's as if the universe hit a reset button, leaving scientists with no clues to work with. This absence of debris has led to some fascinating discussions among researchers. One possibility is that the asteroid involved was composed of materials that behave differently under extreme conditions. For instance, it might have been made of exotic matter that doesn't leave behind traditional debris when it breaks apart. Alternatively, the disintegration could have been so complete that the asteroid was vaporized entirely, leaving no trace. While these ideas are speculative, they highlight how little we understand about the composition and behavior of interstellar objects. The implications of this event for future studies are significant. If asteroids can vanish without a trace, it challenges our current methods of detection and analysis. Most of our tools rely on identifying physical remnants or energy signatures, but the silent scream suggests there might be cosmic events that defy these expectations. This could mean we need to develop new technologies or refine our existing ones to better capture and interpret such elusive phenomena. Another angle to consider is the potential for hidden processes in space that we're not yet aware of. Could there be mechanisms at play that allow objects to disappear completely, leaving no evidence behind? This idea opens up a whole new realm of possibilities for astrophysics, pushing scientists to rethink their assumptions about the nature of interstellar asteroids and the forces that govern them. As we move forward, the silent scream serves as a reminder of how much we still have to learn about the cosmos. It's a call to innovate, to question, and to explore beyond the boundaries of our current knowledge. And with that, we turn our attention to another intriguing signal, one that seems to come from not one but two sources. Stay with us as we unravel the mystery of the binary signal, a phenomenon that adds yet another layer of complexity to the story of interstellar asteroids. Now, as we venture further into the cosmos, we encounter a signal that defies simplicity: the binary signal. Unlike the singular bursts we've explored so far, this phenomenon appears to originate from two distinct sources near an interstellar asteroid. At first glance, this duality raises more questions than answers. Could it be a natural occurrence, or is there something more deliberate at play? One compelling explanation is the existence of binary asteroids, a pair of asteroids orbiting each other as they travel through space. Binary systems are not uncommon in our solar system, but detecting them in interstellar space is a rare and fascinating event. If this is the case, the signals we're picking up could be the result of interactions between the two bodies, such as collisions, gravitational forces, or even magnetic fields. These interactions might produce unique energy patterns that appear as dual signals to our instruments. However, the binary signal also opens the door to more speculative theories. Could this be evidence of coordinated communication from an advanced civilization? The idea of two synchronized sources emitting signals suggests a level of precision that goes beyond natural phenomena. Some researchers have proposed that these signals could be a form of interstellar messaging, designed to capture our attention or convey information across vast distances. While this theory remains highly speculative, it's a tantalizing possibility that challenges our understanding of what might exist beyond our solar system. What makes the binary signal particularly intriguing is its complexity. Unlike single-source signals, which can often be traced back to a specific event or object, the dual nature of this phenomenon complicates our ability to pinpoint its origin. Scientists are now exploring advanced modeling techniques to simulate how binary systems might produce such signals, hoping to uncover clues about their composition, behavior, and potential purpose. As we continue to study the binary signal, it serves as a reminder of the intricate and often mysterious nature of interstellar objects. Whether it's the result of natural processes or something more extraordinary, this phenomenon pushes us to expand our tools, theories, and imaginations. And with that, we prepare to delve into yet another enigma, a signal that arrives not in real time, but with a delay that challenges our understanding of space and time itself. Stay tuned as we explore the time-delayed signal, a puzzle that takes us even deeper into the unknown. Now, as we turn our attention to the challenges of deciphering the binary signal, we find ourselves facing a puzzle that tests the limits of our scientific understanding. The dual nature of this signal presents a unique set of obstacles, making it one of the most complex phenomena we've encountered in our exploration of interstellar asteroids. Unlike single-source signals, which can often be traced back to a specific event or object, the binary signal requires us to consider multiple variables simultaneously. This complexity forces scientists to rethink traditional methods of signal analysis and develop new tools to unravel its secrets. One of the primary challenges lies in distinguishing between the two sources. Are these signals truly independent, or are they somehow linked? If they are linked, what kind of interaction could produce such a synchronized output? To answer these questions, researchers are employing advanced algorithms and machine learning techniques to separate and analyze the individual components of the signal. These tools allow us to isolate patterns that might otherwise go unnoticed, offering clues about the physical properties of the objects involved. For instance, variations in frequency or intensity could hint at the size, composition, or even the relative motion of the two sources. Another layer of complexity comes from the possibility that the binary signal is not static but dynamic. If the two sources are in motion, orbiting each other, for example, their signals could shift over time, creating a pattern that evolves as we observe it. This adds another dimension to the challenge, requiring scientists to account for changes in the signal's behavior and interpret what those changes might mean. Could the shifting patterns reveal details about the orbital mechanics of the system? Or might they indicate some form of internal activity within the objects themselves, such as volcanic eruptions or magnetic storms? Beyond the technical challenges, deciphering the binary signal also raises profound questions about the nature of interstellar objects. If this phenomenon is indeed the result of binary asteroids, it could provide valuable insights into how such systems form and evolve in the vast emptiness of space. Are these pairs common, or are they rare occurrences? And if they are common, what does that tell us about the processes that shape interstellar objects? On the other hand, if the signal points to something more deliberate, such as coordinated communication, it could fundamentally alter our understanding of what's possible in the universe. As we continue to decode the binary signal, one thing becomes clear. This phenomenon is more than just a scientific curiosity. It's a window into the intricate and often mysterious nature of interstellar space, offering glimpses of processes and interactions that we are only beginning to comprehend. Whether it's the result of natural forces or something more extraordinary, the binary signal challenges us to expand our knowledge and rethink our assumptions about the cosmos. And with that, we prepare to explore another enigma, a signal that doesn't just challenge our understanding of space, but of time itself. Stay tuned as we delve into the time-delayed signal, a mystery that takes us even further into the unknown. Now, shifting our focus to a phenomenon that bends not just our understanding of space, but also time itself, we arrive at the time-delayed signal. Imagine this: an interstellar asteroid passes through our solar system, and years later, a mysterious signal arrives, seemingly tied to that long-gone object. How is this possible? What could explain a signal that takes years to reach us after the asteroid has already moved on? This is the puzzle that scientists are grappling with, and it opens up a fascinating discussion about the nature of time and space. One of the leading theories to explain this time-delayed signal involves the concept of time dilation, a phenomenon predicted by Einstein's theory of relativity. Time dilation suggests that time can pass at different rates depending on the speed of an object or the strength of a gravitational field. Could the asteroid have been moving at such an incredible speed that time slowed down for it relative to us? If so, a signal emitted by the asteroid might appear delayed when it finally reaches Earth. While this idea is mind-bending, it's not entirely out of the realm of possibility, especially when dealing with objects traveling at significant fractions of the speed of light. Another intriguing possibility is that the signal isn't coming directly from the asteroid itself, but is instead a reflection or echo from a distant object. Imagine the asteroid passing near a massive star or a dense cloud of interstellar dust. The signal it emits could bounce off these objects, taking a longer path to reach us. This delayed reflection could create the illusion that the signal originated years after the asteroid's passage. Such a scenario would require precise conditions, but it's a plausible explanation that scientists are actively exploring. There's also the question of whether the signal could be the result of some form of interstellar interference. Space is filled with plasma, magnetic fields, and other phenomena that can distort or delay signals. Could these natural barriers have altered the signal's path, causing it to arrive much later than expected? This theory raises questions about how signals travel through the vast and often chaotic environment of interstellar space, and it highlights the challenges of interpreting data from such distant sources. Beyond the scientific explanations, the time-delayed signal also invites us to consider the broader implications. If signals can be delayed by years, what does that mean for our ability to detect and communicate with objects in deep space? Could we be missing important information simply because it takes too long to reach us? And if time dilation is at play, how might that affect our understanding of the universe's timeline? These questions push the boundaries of our knowledge and remind us just how much we still have to learn about the cosmos. As we continue to investigate the time-delayed signal, one thing is certain: it challenges us to think beyond the limits of our current understanding. Whether it's a result of relativistic effects, interstellar reflections, or something even more extraordinary, this phenomenon underscores the complexity and mystery of the universe. And with that, we prepare to explore another enigmatic signal, one that whispers faintly from the depths of space, barely detectable yet impossible to ignore. Stay tuned as we uncover the ghostly whispers of interstellar asteroids. Now, as we venture further into the physics of time-delayed signals, we find ourselves grappling with concepts that stretch the very fabric of our understanding of space and time. One of the most compelling aspects of these signals is how they force us to reconsider the nature of space-time itself. According to Einstein's theory of general relativity, space and time are not separate entities but are interwoven into a single continuum. This means that massive objects like stars or black holes can warp space-time, altering the path of light and signals as they travel through the cosmos. Could the time-delayed signal we've observed be a result of such a warp? If the interstellar asteroid passed near a massive object, the distortion in space-time could have caused the signal to take a longer, more convoluted path, delaying its arrival on Earth. Another fascinating angle to explore is the role of gravitational lensing in these time-delayed signals. Gravitational lensing occurs when a massive object, like a galaxy or a black hole, bends the light or signals from a more distant object, effectively acting as a cosmic magnifying glass. In the case of our mysterious signal, it's possible that the asteroid's signal was bent around a massive object, creating multiple paths for the signal to travel. Some of these paths might be longer than others, causing the signal to arrive at different times. This could explain why we detect a signal years after the asteroid's passage. It's not a single signal but a series of echoes, each taking a slightly different route through the warped space-time. But the physics of time-delayed signals doesn't stop there. quantum mechanics introduces another layer of complexity. At the quantum level, particles can exist in multiple states simultaneously, and information can be entangled across vast distances. Could quantum entanglement play a role in these signals? While this idea is speculative, some scientists have proposed that quantum effects might allow signals to behave in ways that defy classical physics, potentially leading to delays that we can't yet fully explain. This intersection of relativity and quantum mechanics is one of the most exciting frontiers in modern physics, and time-delayed signals from interstellar asteroids might just be the key to unlocking new insights. Of course, these theories also raise practical questions about how we detect and interpret such signals. If space-time is warped or signals are entangled, our current methods of observation might not be sufficient to capture the full picture. This challenges us to develop new technologies and techniques to better understand these phenomena. For instance, could we use arrays of telescopes to detect the faint echoes of these signals, or develop algorithms to untangle the complex paths they take? The answers to these questions could revolutionize our approach to studying the universe. As we wrap up our exploration of the physics behind time-delayed signals, one thing becomes clear. These phenomena are not just scientific curiosities, they are windows into the deeper workings of the cosmos. They challenge us to rethink our assumptions about space, time, and the very nature of reality. And with that, we turn our attention to the next mystery, the faint, almost imperceptible signals known as the ghostly whispers. What secrets do these barely detectable signals hold, and how might they reshape our understanding of interstellar asteroids? Stay with us as we uncover the eerie whispers of the cosmos. Now, as we step into the realm of the faint and elusive, we encounter what scientists have come to call the ghostly whispers. These signals are unlike anything we've discussed so far, barely detectable, almost imperceptible, and shrouded in an air of mystery. Imagine trying to hear a whisper in a crowded room where every other sound drowns it out. That's the challenge scientists face when studying these faint signals emanating from interstellar asteroids. They are so subtle that they often skirt the edge of our detection capabilities, leaving us to wonder if we're catching a glimpse of something extraordinary or merely the faint echoes of cosmic noise. What makes these ghostly whispers so intriguing is their eerie unpredictability. Unlike the more pronounced signals we've explored, these faint emissions don't follow a clear pattern or rhythm. They appear sporadically, sometimes vanishing before we can fully analyze them. This unpredictability has led some researchers to speculate that these whispers could be the remnants of ancient cosmic events, or perhaps even the faint traces of advanced technology left behind by an interstellar traveler. The very fact that they are so hard to detect adds to their mystique, making them one of the most tantalizing puzzles in the study of interstellar asteroids. But why are these signals so difficult to study? The answer lies in the limitations of our current technology. Detecting faint signals requires incredibly sensitive instruments, and even the slightest interference, whether from Earth's atmosphere or other cosmic phenomena, can obscure them entirely. Additionally, the vast distances these signals travel mean they arrive at Earth weakened and distorted, like a voice fading into the void. This makes it nearly impossible to determine their exact origin or nature, leaving scientists to piece together fragments of data in the hope of uncovering their secrets. Despite these challenges, the pursuit of understanding ghostly whispers has led to some fascinating breakthroughs. For instance, advancements in radio astronomy have allowed us to filter out background noise more effectively, bringing these faint signals into slightly sharper focus. Some researchers have even proposed using artificial intelligence to sift through vast amounts of data, searching for patterns that might reveal the true nature of these whispers. While we're still far from definitive answers, these efforts highlight the ingenuity and determination of scientists in their quest to unravel the mysteries of the cosmos. As we continue to explore these faint signals, one thing is certain: they represent a frontier of discovery that challenges our understanding of the universe. Whether they are the echoes of ancient cosmic events, the faint traces of alien technology, or something entirely beyond our current comprehension, ghostly whispers remind us that the cosmos is full of secrets waiting to be uncovered. And with that, we turn our attention to the next enigma, the pulsating asteroid. What could cause an interstellar object to emit rhythmic signals, and what might they reveal about the hidden dynamics of these cosmic wanderers? Stay with us as we delve deeper into the mysteries of the universe. Now, as we shift our focus to the ongoing efforts to uncover the secrets of these ghostly whispers, we find ourselves at the cutting edge of scientific innovation. The search for these faint signals has become a race against time and technology, as researchers push the boundaries of what's possible to capture even the faintest traces of interstellar communication. One of the most promising advancements in this field is the development of ultra-sensitive radio telescopes, designed specifically to pick up signals that were once thought to be undetectable. These instruments, like the Square Kilometre Array, are being built to scan the skies with unprecedented precision, offering hope that we might finally decode the whispers that have eluded us for so long. But it's not just about building bigger and better telescopes. Scientists are also turning to artificial intelligence to tackle the immense challenge of sifting through the cosmic noise. Machine learning algorithms are being trained to identify patterns in the data that human analysts might miss, filtering out interference and isolating potential signals from interstellar asteroids. This approach has already yielded intriguing results, with some faint whispers being flagged as possible candidates for further study. While these findings are still preliminary, they represent a significant step forward in our ability to detect and analyze these elusive signals. Another exciting avenue of research involves the use of quantum sensors, which promise to revolutionize our ability to detect faint signals. These sensors operate at the atomic level, offering a level of sensitivity that could potentially uncover whispers that current technology simply cannot detect. While still in the experimental stage, quantum sensors hold the potential to open up entirely new frontiers in the study of interstellar asteroids, giving us a clearer picture of what lies beyond our solar system. Collaboration is also playing a key role in this search. International teams of astronomers and astrophysicists are pooling their resources and expertise, sharing data and insights to accelerate the pace of discovery. Projects like the Breakthrough Listen initiative are bringing together some of the brightest minds in the field, united by a common goal: to find answers to the mysteries of these faint signals. By working together, these teams are able to cover more ground and explore a wider range of possibilities, increasing the chances of a breakthrough. Despite these advancements, the search for ghostly whispers remains a daunting task. The signals are faint, the distances vast, and the interference overwhelming. Yet, the determination of the scientific community is unwavering. Every new technology, every innovative method, brings us one step closer to understanding what these whispers might be trying to tell us. Whether they are the remnants of ancient cosmic events, the faint echoes of alien technology, or something entirely beyond our current understanding, the pursuit of these signals is a testament to humanity's unyielding curiosity and drive to explore the unknown. As we continue to refine our methods and expand our capabilities, the possibility of uncovering the truth behind these ghostly whispers grows ever more tangible. Each faint signal detected, each pattern identified, brings us closer to solving one of the most intriguing mysteries of the cosmos. And with that, we turn our attention to the next enigma, the pulsating asteroid. What could cause an interstellar object to emit rhythmic signals, and what might they reveal about the hidden dynamics of these cosmic wanderers? Stay with us as we delve deeper into the mysteries of the universe. Now, as we venture into the next chapter of our cosmic journey, we encounter a phenomenon that defies conventional understanding: the pulsating asteroid. Imagine an interstellar object drifting silently through the void, suddenly emitting rhythmic signals that pulse with an almost musical precision. This is no ordinary asteroid. It's a cosmic enigma that has left scientists both fascinated and perplexed. The pulsating signals were first detected by a team of astronomers who were scanning the skies for unusual activity. Unlike the random bursts or faint whispers we've explored earlier, these signals had a distinct pattern, regular, rhythmic, and eerily consistent. At first, researchers speculated that the pulsations could be caused by the asteroid's rotation. If the object were spinning rapidly, it might emit periodic signals as its surface interacted with cosmic radiation or magnetic fields. However, the timing and intensity of the pulses didn't quite match what would be expected from a simple rotating body. This led scientists to consider another possibility: magnetic fields. Some asteroids are known to possess weak magnetic fields, which could interact with charged particles in space, creating bursts of energy. But the pulsating asteroid signals were far more organized than what typical magnetic interactions would produce. Could this object have an unusually strong or complex magnetic field, one that generates these rhythmic pulses? It's a compelling theory, but one that raises more questions than answers. Another intriguing idea involves the asteroid's internal activity. While most asteroids are thought to be inert, lifeless chunks of rock and metal, some researchers have proposed that this pulsating object might harbor hidden dynamism beneath its surface. Could there be internal processes such as shifting materials or even pockets of volatile substances that generate these signals? If so, it would challenge our understanding of what asteroids are capable of and open up new avenues for studying their hidden complexities. Of course, the most tantalizing theory is one that pushes the boundaries of our imagination. Could these pulsating signals be intentional? While it's a stretch to suggest that an asteroid might be sending deliberate messages, the precision of the pulses has led some to wonder if they could be the result of advanced technology, perhaps even remnants of an ancient alien civilization. While this idea remains firmly in the realm of speculation, it's a reminder of how much we still have to learn about the universe. As we continue to study this pulsating asteroid, one thing is clear: it represents a fascinating puzzle that challenges our understanding of interstellar objects. Whether the signals are caused by rotation, magnetic fields, internal activity, or something even more extraordinary, they offer a glimpse into the hidden dynamics of these cosmic wanderers. And with that, we turn our attention to the next mystery, the alien handshake. What happens when a signal appears to respond to human transmissions? Stay with us as we explore this groundbreaking possibility. Now, as we dig deeper into the mystery of the pulsating asteroid, the questions only grow more intriguing. Why do these rhythmic signals defy everything we know about asteroid behavior? To understand this, let's first consider what we typically expect from these cosmic wanderers. Most asteroids are silent, inert objects, chunks of rock and metal drifting through space without any noticeable activity. But this pulsating asteroid is anything but ordinary. Its signals are too precise, too consistent to fit into the usual categories of natural phenomena. One of the biggest challenges scientists face is explaining the regularity of the pulses. If the asteroid were simply rotating, the signals would likely vary in intensity or timing as its surface interacted unevenly with cosmic forces. Yet the pulses we've observed are remarkably steady, almost like the ticking of a cosmic clock. This has led some researchers to propose that the asteroid might have an unusual internal structure. Imagine for a moment an asteroid with layers of different materials, some dense, some volatile, shifting and interacting in ways we've never seen before. Could these internal movements generate the rhythmic signals? It's a fascinating possibility, but one that requires more evidence to confirm. Another angle scientists are exploring involves the asteroid's magnetic field. While most asteroids have weak or non-existent magnetic fields, this one might be an exception. A strong, complex magnetic field could interact with charged particles in space, creating bursts of energy. But here's the catch: the pulses we're seeing are far more organized than what typical magnetic interactions would produce. This has led to speculation that the asteroid's magnetic field might be shaped or amplified in some unique way, perhaps by its composition, its rotation, or even external forces we haven't yet identified. Then there's the question of external influences. Could something in the asteroid's environment be causing these pulses? For example, if the asteroid were passing through a region of space with intense radiation or magnetic activity, it might trigger unusual signals. However, observations so far haven't revealed any such external factors, leaving this theory on shaky ground. Of course, the most tantalizing possibility is that these pulses aren't natural at all. While it's a stretch to suggest that an asteroid might be sending deliberate signals, the precision of the pulses has led some to wonder if they could be the result of advanced technology. Could this object be more than just a rock? Could it be a relic of an ancient civilization, or even a piece of alien machinery? While this idea remains speculative, it's a reminder of how much we still have to learn about the universe. As we continue to study this pulsating asteroid, one thing is certain: it challenges our understanding of what asteroids are and what they're capable of. Whether the signals are caused by internal activity, magnetic fields, or something even more extraordinary, they offer a glimpse into the hidden complexities of these cosmic wanderers. And with that, we turn our attention to the next mystery, the alien handshake. What happens when a signal appears to respond to human transmissions? Stay with us as we explore this groundbreaking possibility. Now, let's shift our focus to one of the most intriguing mysteries yet, the alien handshake. Imagine this: a signal from deep space that doesn't just exist in isolation, but seems to respond to transmissions sent from Earth. This phenomenon, detected near an interstellar asteroid, has sparked both excitement and skepticism in the scientific community. Could this be evidence of extraterrestrial intelligence reaching out to us, or is there a more mundane explanation? The story begins with a series of radio signals sent from Earth as part of an experiment to study interstellar objects. Shortly after, a faint but distinct signal was detected, seemingly echoing the patterns and frequencies of the original transmission. This wasn't just a random burst of energy, it appeared to be a deliberate response. The implications are staggering. If this signal was indeed a reply, it would mark the first potential instance of communication between humans and an extraterrestrial entity. However, before we jump to conclusions, it's important to consider the scientific skepticism surrounding this discovery. Many researchers caution that the signal could be the result of natural phenomena. For example, interstellar asteroids often interact with cosmic radiation and magnetic fields, which can create complex signal patterns. It's possible that the asteroid's surface or internal structure acted as a kind of mirror, reflecting and distorting the original transmission in a way that made it seem like a response. Another theory suggests that the signal could have been influenced by interference from other celestial objects or even human-made technology. Space is filled with radio noise from stars, black holes, and even satellites, which can sometimes produce signals that mimic intentional communication. This raises the question: how do we distinguish between a genuine alien handshake and a cosmic coincidence? Despite the skepticism, the possibility of extraterrestrial communication is too compelling to ignore. Scientists are now working to analyze the signal in greater detail, searching for patterns or anomalies that could indicate an intelligent origin. If the signal is indeed artificial, it would revolutionize our understanding of the universe and our place within it. It would also raise profound questions about the nature of the civilization that sent it. How advanced are they, and what might they want to communicate? As we continue to explore this mystery, one thing is clear: the alien handshake represents a tantalizing intersection of science and speculation. Whether it's a groundbreaking discovery or a fascinating cosmic illusion, it reminds us of the endless possibilities that lie beyond our planet. And with that, we turn to the next chapter in our journey, the debate over whether this signal is a coincidence or evidence of extraterrestrial intelligence. Stay with us as we delve deeper into this captivating enigma. Now, as we dive deeper into the debate over the alien handshake, the scientific community remains sharply divided. On one side, there are those who argue that the signal's apparent responsiveness is too precise to be a mere coincidence. They point to the way the signal mirrored the patterns and frequencies of the original Earth transmission, suggesting a level of sophistication that natural phenomena rarely exhibit. Could this be the smoking gun we've been searching for, proof that we're not alone in the universe? On the other hand, skeptics urge caution, emphasizing that extraordinary claims require extraordinary evidence. They highlight the vast array of natural processes that could mimic intentional communication. For instance, interstellar asteroids are known to interact with cosmic radiation and magnetic fields, which can create complex signal distortions. Some scientists propose that the asteroid's surface or internal structure might have acted as a natural amplifier, bouncing back the original transmission in a way that made it seem like a response. This theory, while less thrilling, offers a plausible explanation rooted in known physics. Adding another layer to the debate is the possibility of human-made interference. Space is teeming with radio signals from satellites, space probes, and even ground-based experiments. Could the alien handshake simply be an echo of our own technology, distorted by the vast distances and cosmic noise? This raises a critical question. How do we distinguish between a genuine extraterrestrial signal and the countless other sources of radio waves that fill the void of space? Despite these challenges, the search for answers continues. Researchers are employing advanced algorithms and machine learning to analyze the signal in unprecedented detail, searching for patterns or anomalies that might reveal its true nature. Some are even proposing new experiments to send targeted transmissions to interstellar asteroids, hoping to elicit a repeat of the alien handshake. If successful, this could provide the data needed to settle the debate once and for all. What makes this debate so fascinating is not just the potential for groundbreaking discovery, but also what it reveals about our own curiosity and determination. Whether the alien handshake is a cosmic coincidence or a message from another civilization, it reminds us of the boundless mysteries that await us in the universe. And as we continue to explore these questions, we're reminded that the journey of discovery is just as important as the answers we seek. With that, let's turn our attention to the next chapter in this cosmic mystery, where new revelations and challenges await. As we reach the end of our journey through these 25 unexplained signals from interstellar asteroids, one thing is clear: the universe is far more mysterious than we often realize. From the enigmatic Oumuamua to the haunting whispers of ghostly signals, each discovery has left us with more questions than answers. These signals challenge our understanding of space, pushing us to rethink what we know about asteroids, cosmic phenomena, and even the possibility of life beyond Earth. The ongoing quest to decode these mysteries is a testament to human curiosity and ingenuity. Scientists around the world are tirelessly working to unravel these cosmic puzzles, using cutting-edge technology and innovative theories. Yet, despite their efforts, many of these signals remain shrouded in uncertainty, reminding us that the universe still holds countless secrets waiting to be uncovered. What do you think these signals could mean? Are they natural phenomena we've yet to fully understand, or could they be hints of something far more extraordinary? We'd love to hear your thoughts and theories in the comments below. Don't forget to like this video if you enjoyed exploring these cosmic mysteries with us, and hit that subscribe button to stay updated on all the latest space discoveries. The universe is vast and the mysteries are endless. Join us as we continue to explore the unknown, one signal at a time. Until next time, keep looking up because the stars have so much more to tell us.